Hello, and welcome to a series of 3 lectures on text analysis. We'll walk through the motivation, implementation, and then evaluation. So each one of them should take you about 10 minutes, and then we'll ask you to answer a set of questions associated with also the papers that we're asking you to read. As with everything, I draw heavily on my colleagues and other experts in the field. So when I first got interested in the tremendous value of computer science for social science and for policy, that was in the early 2000s, and I was amazed by what could be learned from particularly text. This was an era of the Brown Corpus, and a tremendous amount of information was available by understanding how people interacted through words. And this was a whole new area for us. And even now, when people talk about computer science and the massive breakthroughs, an awful lot of it has to do with the work on text analysis. It's an incredibly rich area. We'll talk about that a little bit. As with any data, it requires substantial processing. And as you'll see, text analysis and natural language processing, there are many, many different ways of approaching it. It depends on the question. We're going to spend a bit of time talking about topic modeling because that's probably the easiest to understand and also the most widely used. We'll talk a little bit about evaluation. So there's lots of questions that we have to face when we're dealing with policy. There's questions like, and I'm obviously going to use science policy in this area because that's what the book is about, and most of the information is open source, so it's much easier to use these examples. Many of you will be familiar with the questions for the record. How much does the United States spend on biofuel-related science funding? Or as we'll see, how much do we spend on research in food safety? In election campaigns, who's winning the debate? How do we read the text of all the different things that people are sending out in Twitter and on Facebook and so on, the social media? And, you know, I do find the work that the National Center for Science and Engineering Statistics does is very interesting. And so one of the things they're interested in doing is categorizing areas of research that are being funded. How do we find the answers to those questions? So all of those can be addressed with text analysis. But what do we mean by text? Well, you think of text as a bunch of words, but actually it's a bit more than that. The words in a language are linked. And so the way in which they're linked has meaning. Some of those can have ambiguity. So you've got to make sense of the semantic context. And of course, many of the words can be ambiguous in multiple languages. So, you know, when you're thinking about sentiment analysis and in Twitter and Facebook, when there's an election debate going on, for example, people could be talking in Spanish, they could be speaking Chinese, or German, or Thai, or English, and then you're trying to figure out what makes sense in those. Another term that we need to think about is, what is a document? And you think, I know what a document is. Well, it's got a very specific meaning when you're doing text analysis. It's a purposefully organized text written in a given genre and style and for a specific audience. And so the basic idea here is we're interested in describing exactly how the text is structured and why is it structured. So obviously I just talked about the different languages in which it's organized. You need to think about the style. An email, a corpus that is built on emails is going to be very different from a set of documents that are scientific articles, which are different from a set of government policy reports, which are different from a set of questions for the record. And so each one has its own, each set of documents has its own style and purpose, and it has a different target audience. So understanding how, in other words, the data generating function, which is the way in which the people are using the words in the document to convey meaning is a very core concept when you're dealing with text analysis. In what I just said, I referred to a corpus. That's a collection of documents. So there are some very standard corpora that are available to computer scientists who want to test their algorithms, test their natural language processing techniques. In what we do in the book is we talk about award abstracts and dissertation abstracts and patents, because those are readily available and make a lot of sense to, I think, a lot of people. But each of those is an example of a corpus. Now, obviously, as I said before, there's an enormous amount of things you can do with the text. Machine translation, many of you will have used, where you get an email from a friend, or you're trying to read a scientific document that's in one language that you don't read. You put it into Google Translate, and out pops the English version with varying degrees of quality. I had a really good experience. I was in Brazil for a wedding last year, and I didn't speak a word of Portuguese. The driver who came and picked me up didn't speak a word of English. He had a translation app on his phone. He spoke into it in Portuguese. It came out actually in almost perfect English. I then spoke in English, translated to Portuguese. It worked beautifully. So here we have an example of text analysis, although in not written text, but oral text, making a real difference in the way in which people can communicate. Absolutely massive value here. You can do things for purpose. There is a guy at NYU who's been trying to figure out whether documents should, from WikiLeaks, should have been classified as sensitive or not sensitive. So he applies text analysis to figure out what documents, how documents are classified. We'll see in a minute, trying to figure out whether scientific abstracts should be classified as food safety or not food safety. And so there are lots of different things that you can do with text. And very specifically, you can use it to organize information. You don't have to read all those books and read millions of scientific articles. You could apply natural language processing and look at it. You can visualize, you can summarize information, you can search for books or search for text, you can predict trends, or you can understand what people are saying. So those are very, very different activities. Obviously, they're going to require different tools. And so, you could think of all of these different tools as being used, and each one of them is a different approach to thinking about text analysis. One of the things that we talked about in record linkage is named entity extraction. How do we find whether a person is the same person, whether a location is the same location? It requires looking at text and making sure that they're the same. What we're going to talk about in a minute is search. How do I find the food safety documents? Summarizing. So there's many, many different tools. So obviously there are different approaches. Back in the day, the only way in which you could do things is do it by hand. So, for example, when you were thinking about librarians and information science, they had to classify documents. So what they would do is they would try and put it into a Dewey Decimal System or a classification system, and they'd use it based on a set of words in the that described a book or whatever. So you could do that by hand. You could have a list of words, and you'd say, if I see that word, it's going to go into that bucket. Or you could hire linguists, so people who are highly skilled in trying to figure out how to organize language. Or you can develop statistical approaches. And so what our focus is going to be over these set of lectures is looking at the statistical approaches. So effectively, it's very, very similar to the machine learning that we talked about, record linkage. These ideas are very similar to the types of work that you've done in statistics or econometrics. It's just applying it to this new set of problems. One thing to be careful about, even though this is a big data class or a data science class, we are better off having a carefully curated set of documents that are more homogeneous than billions and billions of documents. You really want, when you're doing text analysis, what you want to do quite often is less is more, because you want to have as similar a unit data generating function in order to be able to do all the scientific statistical tasks that are necessary for the purpose. So let me get very specific. What we were interested in a particular project, a friend of mine, Kay Husbands-Feeling, was working at the University of Minnesota, and they were interested in food safety. So it turns out food safety is a big problem. Lots of people get sick. If we were in a class right now, I'd ask you to raise your hand and tell me how many of you had food poisoning, and almost everyone would have had food poisoning. It costs a lot of money and affects a lot of people. So here's the problem. How do we find out how much food safety research is being done, and what's the economic value of that research? So Kay got really interested in this, pulled me in and a couple of other colleagues in. And so we wrote this book on measuring the economic value of research, with food safety research as being the focus. Well, step number one is defining food safety. Well, turns out that's a problem. We don't have a naturally occurring bucket. And this happens all over the place, right? You know, we have buckets that are generated for industry codes and occupation and all kinds of other things. Spend lots of time grouping people into occupations or grouping firms into industries, and everything changes all the time. So one of the things that you might want to do is to use text analysis to characterize human activity in different ways than maybe the statistical system has put together. The case of food safety, it's all the way through the spectrum. Production of food, the preparation of food, in cans, for example, processing, shipping, consumption, the way in which you prepare food to go to the table in restaurants. So there's not a natural bucket to think about. And the words that are used to describe food safety can be very different. So how are we going to go about figuring out what research in food safety is funded? Because that's at the core of what we wanted to do. We're interested in finding out, first of all, what's funded, then who's funded, and what are the results. If you're looking at the impact of investments in a particular field, the first thing is to say, how much is spent in that field? So doing the text analysis was critical. And it turns out it's not easy from a practical point of view. For example, when you look at NSF, this is the way an abstract is described. They have goals, project, foci, the intellectual merit, broader impact, and on the right is an NIH description. And so what we were able to do is to use text analysis to bucket the food safety fields from looking at the NSF corpus, then do the same for the NIH corpus. This list is what's called a topic model. We were able to do the same for USDA. We treated them each as a separate corpus because the text was structured in such a different way. And what then we were able to do is figure out how many grants had been made in food safety, and it turned out to be about 1,100. So there's your initial introduction. I'm going to encourage you to go and answer the questions on the class website, and then go to the next lecture.